All righty. Well, hey everybody, thank you for joining us today for the AWS Michigan meetup. We've got Brian Korzynski today, and he's going to be presenting a cloud comparison. Pretty exciting stuff. If you guys haven't checked out Great Lakes Tech Leaders just yet, really cool. We moved from Slack to Discord. We've got some cards there, so check it out. It's awesome. We host Lunch with Tech Leaders every single week there, our podcast. We're always looking for the more the merrier, and if you're interested in hosting a topic as well, you could do that as well. And without any further ado, we'll toss it to Brian. Before I do, we've got this catch box here, so if you guys have any questions or anything, we'll toss it around the room. You can talk right into it like this, and we'll be able to hear everything. So take it away, Brian. Thank you.
Well, thank you. Thank you for having me on. So a little bit about me. Normally, I would do the whole hand thing. I'm from here, but since we're all in Michigan, I think that's kind of pointless. I'm from the other side of Metro Detroit, up in Macomb. I work as a principal architect at a company called Iron Mountain. Been doing development now for a little over 14 years, mostly in the Microsoft stack, although a lot of the stuff I've been doing is cloud and more recently machine learning. So a lot of the stuff I'm doing now is actually more Python related. So a couple disclaimers I wanna put out there. So the thing that we're gonna talk about today is, if we stop and think about cloud, like how do you compare the clouds, right? It's really hard to just say, oh, I'm gonna compare Azure to AWS, right? Well, there's too big a thing to compare, right? So the only way you can really compare it is you have to look at the different offerings and how do the different offerings compare to one another. So with that, there's so many offerings that are in these. We're only going to focus on the things that are most often used, and I want to talk about like my experiences and some of the stuff that I've done. It's only going to be an overview, so we're not going to go super deep into any one particular thing. I'm going to talk about some of the differences as they come up around the different services. So it'll give you a better idea of what to pick if you're trying to move from, say, AWS to Azure or AWS to GCP. I'll share my experiences. I've had the I've been very fortunate to be able to work in all three cloud platforms. At my current job, we work primarily in AWS and GCP, although I've done Azure for well over 10 years. So I've been pretty well versed and used a lot of the services and offerings. So I know a lot of the pitfalls, things that have worked, things that haven't worked. So if we have any questions and stuff, please feel free to ask. I'd be more than happy to answer to the best of my ability. And the other big thing is I don't really want to get into pricing. The reason why is when you're looking at different services, they're going to be very comparable in pricing, right? And pricing changes from day to day. So if I would have done this, a week ago and I put all the pricing in here, everything could be completely different today. So that's why I don't really like talking about pricing. I want to give you guys the information that you can do the research to figure out what services you're interested in. And then from there, you can do a price comparison. Since I'm new to this user group, I don't really know anybody's backgrounds or what kinds of things people are working on. So has anybody in here used cloud platforms other than AWS? Which platforms you guys are on?
It's our own OpenStack.
Okay, so you got an OpenStack. How about you? GCP? Azure, okay. So it sounds like a pretty good variety. Some Azure, some GCP, and some private cloud. So what kind of programming languages are you guys working in? You guys .NET? You guys Python? Python? Kind of all over the board.
Whatever the client has.
That's good. I like that. So what kinds of applications are you guys building? You guys doing like a lot of microservices and distributed? Doing a lot of web apps? Are you primarily using the cloud for like file storage and that kind of thing?
Discord bots.
Discord bots?
My most recent project.
IoT? Okay, yeah, IoT is a big one. That's a huge one. RDS? Yep, that's a really good one as well. All right, cool. So one of the first things we got to talk about, and I'm sure you guys are very familiar with this, is the console, right? So you know that when we're going in AWS, we need to provision services. One of the ways at which we can do that is to go to the console. These screenshots are going to be a little tiny, and And I did want to point out too, all the slides and everything will be available on my GitHub. So don't feel like you have to frantically take notes or anything. You can just download all this and it has all the information in it. And with that, I'm going to have a ton of links in here for more information. Like if you want to check out a service or how to get started with it, I have provided a ton of links in here. So in Amazon, it's called the console. Same thing is true in GCP. So a lot of the terminology of what things are called is very similar between AWS and GCP. Azure likes to be different, and instead of calling it console, they call it the portal. Given that I work in all three cloud platforms, I kind of use these two words interchangeably because I get confused and like sometimes I'll call the console the portal and sometimes I'll call the portal the console and vice versa. But that's one of the big things that I wanted to point out here is that there is a difference between terminology name. Also with command line interfaces, let's say that in Linux, we want to copy a file, right? Well, we can use a CP command, right? So we can say CP, my file, and then the path we want to put it to. Well, if you look at AWS basically takes that Linux command and it allows you to wrap it in AWS. So you can say AWS S3 and then my CP command. So the commands tend to follow the Linux commands. So it doesn't have a really steep learning curve. And it's very easy to utilize the interface. And the thing that's nice about AWS is you actually specify the service you're working with. So I can say AWS S3, do something. AWS SQS, do something. And that's really nice. As you guys are well aware, file paths, when you drop a file in an S3 bucket, you get a unique path that's S3 colon blah, 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 the path to your file. So that makes it really nice to get directly to your file. So I want to compare that a little bit to GCP. So GCP is more contextual, and this might be really hard to see for you guys in the back, but we have a GSUtil, -M. -M means to run this in multi-threaded mode. And then we're going to say CP, and then the command. So the thing that we put into the GCP is going to be contextual. So it says, oh, you want to copy? So that means you're working with GCS. So depending on the command you're doing, it knows what service you're working with to know that it's GCS versus like PubSub. Whereas with AWS, I'm explicitly telling it what service. So just like AWS follows the Linux commands. And also so instead of S3, it's also GS colon //. So it's very similar. So now what I want to talk about is that both of these CLIs are using an authenticated command line. So I don't have to, so if you notice, I'm not passing in any credentials or anything. If you want more information, here's the links for it. But what I want to talk about is I want to compare it to Azure. Azure is vastly different from what we just looked at. This is how we do the same exact thing in Azure. If you notice, it's a lot more parameters, right? We have to pass an account name, container name, the file we're trying to copy, what are we trying to copy it to, what is our authentication mode. And you'll notice it does not follow the Linux commands like the other ones. So this has a much steeper learning curve for learning this if you're already used to using AWS. So we specify additional details. So the thing to note here is that these commands, instead of being Linux commands, these are actually PowerShell commandlets. So the AZ, and then basically this denotes a commandlet. So AZ storage blob, so that tells it I'm working with Azure. I'm using the storage account feature within Azure, and then within that storage account, I'm using the blob feature of that account. And then I'm performing an action. So just like with AWS, I'm actually specifying the service that I want to use. And then again, because my auth mode is login, it's going to prompt me to log in. If I want to do that same authenticated console, I can do this AZ login, and then that'll log me into my console. So as long as my my PowerShell doesn't get killed, then all my commands will be logged in as that. So any questions about that so far? I know a lot of this is really basic, but I wanted to point out the differences because this is vastly different if you're trying to use Azure and you're already familiar with AWS.
I would say that Azure is kind of, well, like you said, it's a PowerShell way of doing things. So I know PowerShell like masks, like, yeah, you can do CPs and stuff like that. They have longer forms that look a lot like that, right? For a lot of things.
Yeah. Yeah, exactly. Yeah, there are, yeah, like you said, there are different ways of doing the commandlets, and there are shorter forms than this, but I'm just, yeah, I just wanted to show you like the basic example, yeah.
If you come in from, if you have a strong background in PowerShell, you think learning Azure is the learning curve?
If you have a background in PowerShell, Azure should be kind of more like your normal, and learning AWS would. I wouldn't say there's a steep learning curve, because if you're already doing PowerShell scripts, you're already familiar with OS commands, even if it's not Linux commands. You're already familiar with, like CD, CP, all like copy, all that kind of stuff. So it's basically just, instead of copy, you put CP. Instead of dir, you put ls. It's like those kinds of things.
This would be on the user side.
Yes.
When I bring people in, migrate into our cloud, I don't do any of that. That's what they would do internal to the cloud, correct?
Yeah, so basically the CLIs are really nice as a developer or somebody who's provisioning the system, because it allows me to programmatically or very quickly just spin up a console, like a cloud console, and be able to like provision a new service on the fly.
You heard of YAML,
Yes. Yep, okay.
orchestration layer?
Yep, yeah, we use like Terraform and some of those other things. Yep. Yep. So we use those type of services instead of doing the commands directly, which is why I don't do these a lot.
So to spin up the VPC and spin up the whole networking and everything, that's what that would do?
It could, yeah, yeah,
That's what YAML does for us.
yeah. Well, the only problem though is you'd have this is just doing one thing. So you would actually have like this is one command. So like in your YAML, you would say I want this this configuration, and then it just runs it. This would be like 20 different commands you'd have to run. So yeah, this is just the CLI, just not like the loading configuration, just calling just interacting with the service.
Yeah, this one you can just modify a little bit. You can change it.
Yeah.
The flavor and
Yeah.
CPU, RAM.
Yep. Yeah. That's completely different.
Okay.
That's more like Terraform or Azure has another one. I can't remember what it's called now. They got like their own variant of it, but Terraform and Ansible are the big ones that work with that. So along the same lines as the SDKs, so as we're aware, SDKs allow us to, programmatically do stuff against our services, right? So let's say that I want to have a service that'll spin up a bucket or pull messages from a queue, those type of things. The big thing to point out is that the SDKs are a really good interface and abstraction around the service, so that you're not making a ton of REST calls or doing a lot of conversion of like response objects back to your objects and things like that. And one of the biggest things, and this is why I point this out, Azure has been known to break things or change things. So if you were not using an SDK and you were making the HTTP calls yourself, there'd be a good chance that URL will eventually at some point change, and then your application will just break. So that's why they always recommend use the SDK instead of making your own calls. It also makes it easier so you don't have to worry about, what am I passing the right headers? Did I put the response in or the request in the right format? All that kind of stuff. Yeah, and we just talked about that. Okay. Basically the SDKs are pretty comprehensive. They basically all do the same thing. There's varying difference of language support. So GCP is by far the most limiting. It basically only supports like C#, Java, and Python, whereas the other two will support all the major languages like C++ and all that, plus like 30 other ones. I just put the main 5 or 6 here. So that's one of the big things to note, is that if you're doing, if you want to use an SDK, then you're going to have to be in one of these type of languages. So let's talk about a little bit about continuous integration. So on AWS, we have a managed build server called Code Build. In Azure, we have something called Azure DevOps. It's basically the same thing, but Azure DevOps is actually a full development environment as well as DevOps tools. And it's definitely the most comprehensive of all these offerings, of all the cloud providers. And why do I say that, right? Well, what DevOps gives you is a managed build server. Same thing as code deploy, right? Or code build, sorry. It gives you a source code repository. It gives you Agile. So it's basically like, you know, your build server plus your GitHub plus your Jira plus, you know, your Jenkins for building, all those kinds of things, all kind of wrapped into one. So it kind of gives you a lot of power, a lot of flexibility. You can do your test plans in there. Once you do your builds through your CI/CD, it can store all those builds for you, so you can deploy them at will. So it kind of acts like almost like a container registry, depending on how you build your apps. And it also has a marketplace, so you can add a ton of additional functionality. So like this is an example of like trying to compare apples to apples. And it's like, well, this apple will do what that apple does, but this apple's like very differently. And that's one of the things I wanted to point out with this. So on GCP, there's not really any known dedicated service specifically for doing this. You can use Cloud Run, and you can build your app and do so basically you would develop your app, build your app, and deploy your app all in the same product, but there's no direct comparison of code build in GCP. Okay? For more information, you got the links here. So on the continuous delivery side of it, we have code deploy, right? This is what allows us to automatically deploy our applications to maintain uptime and things like that. So just like we talked about with DevOps, DevOps, you know, has these CI/CD pipelines. So you might have heard me mention custom CI/CD pipelines a second ago. And basically what that allows you to do is you can build out your entire CI/CD process in a pipeline that says, hey, when you build the product, you know, push it here, do this custom logic, deploy it there. You can basically set all that stuff up and control that pipeline yourself. So it gives you a lot more flexibility than what code deploy does. So cloud deploy is pretty much the same thing. And I haven't really found anything noteworthy difference-wise. It basically is the same exact thing as code deploy. So cloud deploy and code deploy are basically the same exact thing. Okay, so if you guys have any questions, please stop me, by the way. And the other big thing too is that cloud deploy works both on GCP, which is their cloud, and Anthos, which is their on-prem. So we could talk a little bit more about that later on. But basically in the cloud, so basically when you have the cloud, right, you can choose to have the cloud on-prem. Like you can have your own Azure, I think it's called Azure Stack. They'll actually drop off a shipping container, and you actually have your own contained version of Azure. Yeah, exactly. Very, very high amounts of money. AWS has the same thing. I forget what they call it. I have it later in the slides. Yeah, and then Google's is called Anthos. Yeah, it's very high, like that's meant for like enterprise. We need everything locked down. We got billions of dollars. You know, that's the kind of companies that's meant for. API management is another big one. So for those of you that aren't really familiar with API management or what API management is or API gateways, they are fully managed services that allow developers to create, publish, and maintain and monitor their apps. So like when you read this, it's like, okay, well, what the heck does that actually mean, right? So I think it makes a lot more sense to look at a visual of it. So this is a diagram stolen from AWS. Basically what an API gateway is, I have apps that want to use an API, and instead of me directly calling the API, I call the gateway, and the gateway calls the API. So it's a layer of abstraction between my application and my API. And by doing that, I can now do a lot of other things. I can, you know, do load balancing. Maybe I have 5 instances, and I want to load balance across those 5 instances. So I can, you know, have, you know, that distributability and make sure I'm not, you know, losing requests and things like that. So it gives you a lot of power and flexibility there by adding that layer of abstraction there, where you can do certain things like that. You could do like A/B testing, right? Certain percentage of requests will go to this server versus that server. So you could do monitoring and things like that. That's basically why you would use like an API gateway. They're all the oops, sorry, wrong way. All the cloud providers, basically, like I said, there's not really much difference between them. They all basically do the same exact thing. Nothing, I use them all basically the same way. Nothing really worth talking about as far as differences between them. So in AWS, it's called API Gateway. Azure, they call it API Management. That's why some people will use one terminology versus another. And again, GCP follows the AWS format for naming. Next big one is virtual machines. So in AWS, we have the Elastic Compute Cloud. So we all know what VMs are, right? They're secure, resizable compute capacity, right? So they support, Windows and Linux. They support like on-demand, spot, and dedicated instances. So those are really cool because the difference between those is like how you want that VM to reside. So you can have a dedicated that says, hey, I always want this thing up and running. I want my own hardware. I want full access to the resources. Or you could do like on demand. It says, hey, just do this when I tell you, and then it's a lot cheaper. That's why you do one versus the other. And they offer many different sizes, VM sizes as I call it. It's basically CPU, disk, and memory. Azure VMs and the Google Compute Engine, exactly the same thing. Very similar pricing, very similar experience, very similar sizes and things like that. Very, very comparable. This is probably one of the oldest services, and why the clouds actually took off was because of VMs. So at least back when like Azure was starting, everything was a VM at that time. So yep. And one of the things I wanted to point out is I think Google has the coolest name. They call it the Compute Engine. It sounds so ominous, like oh, that's really cool. What's a Compute Engine, dude? I actually like that terminology better than virtual machine. But anyways, some more information, you can go there. But one of the things I want to point out, and this is something I always put in all my cloud talks, you should always prefer PaaS to IaaS wherever possible. So what that means is like, let's say I want to do queuing, right? One approach I could do is I could spin up a VM. I can install RabbitMQ on that machine. And that's the IaaS model, the infrastructure as a service. And now, now I have my Rabbit. But now I have to maintain that OS. I have to worry about security. Scaling is weird now because now I'm scaling up instead of scaling out. And all that kind of stuff. So that's why I always prefer platform as a service. Platform as a service is really nice because it says, hey, I want a queuing service. You worry about the scalability of it. You make sure it's always up to date. You make sure it's, updates don't interfere with my bandwidth and the stuff that I'm processing with it. So that's why one of the things I always point out, because I see that a lot when people are trying to get into the cloud, they always want to go, oh, I'll just go right to VMs. And that's usually the most expensive route because you're paying for that thing to be on, even if you're not using it. Whereas a lot of the PaaS services are pay for only what you're using and that kind of thing. So that's one of the things I want to point out is that I always try to give the advice of always go for PaaS if there's a PaaS option for what you're trying to do instead of just trying to do IaaS. So as far as like web application hosting, we have Elastic Beanstalk. This is what allows us to deploy our applications. It's traditionally meant for non-containerized applications. I'm not sure if Elastic Beanstalk now supports containerized. I haven't used it in quite a while. But the equivalent in Azure was called Azure Static Web Apps, and it's basically the same exact thing. This has gone through several name changes. This used to be called like Azure Websites, Azure Web Jobs. It's changed names so many times over the years that it's like, what are they calling it today? It's like, I don't even know. So like that's one of the things that's kind of tricky with this too. Like even for example, like something that's called Cosmos DB, we'll talk about later in Azure, used to be called Document DB. Then there's Azure Document DB, which is different than Document DB. And it's like, there's like all this naming confusion. That's why I like to have this done in this format. So you can see like, this is a service we're talking about in AWS. This is a service we might use in AWS. These are the two options we would use if we're going to go for GCP or for Azure. The thing to note about Azure Static Web Apps, though, is if you are doing just static pages, static web pages, there are a lot of built-in improvements that actually make those applications faster to run, which you may or may not care about depending on if you're trying to do static web apps. But given the name that it's static web apps, your apps do not have to be static, right? You can deploy any app up there. You just take your code, build it out of Visual Studio or whatever your build system is, deploy it to the cloud, and you're good to go. GCP. It seems to be pretty much the same thing. I don't have a ton of experience with this because I haven't actually deployed any of our apps through App Engine. Most of our stuff, we use Dockerized images. So everything we build a Docker container, and then we deploy those Docker containers. And we'll talk more about that when we get to the Docker stuff. Okay, any questions so far? Good? All right, cool. So if you're doing web APIs or web services now, these are the options you would go. These are meant for when you have containerized applications, where I'm going to take my web service, I'm going to Dockerize it, and now I want to deploy that. So unlike Elastic Beanstalk, this is meant for your containerized apps. That's the difference between using App Runner versus Elastic Beanstalk. So in Azure, again, so now instead of websites, now we're at web service. And then this is where it gets kind of confusing again, right? Because we have Azure static websites, or Azure static apps, rather, sorry, to host, our application, right? With non-Dockerized application, like we've been deploying for like decades now, right? Well, with Azure, you can either use the code or you can use the Docker image, your choice. So now it blurs the line because now it's like, do I use static web apps or do I use app service? And my general thing would say use app service, and I'll tell you why in just a second. Because app service handles a lot of scaling stuff a lot better than the static apps do, and it's also a lot easier to configure and do stuff with your application. So like, for example, like the way you specify like your variables that are going into like, what is my database connection, or where am I storing, my S3 files, that type of thing. Like that configuration stuff is a lot easier to maintain and manage in app service than it is in the static web apps. And one of the other big things too is that app service works really well if you have like a Docker registry and you want to just take your image and deploy it to and basically say, hey, spin this up as an instance. That's really good for that. But one of the things I find even more useful is something called GitHub Actions. You guys familiar with GitHub Actions?
Oh, yeah.
Yeah. So what I like to do is I'll use an app service. So if I'm going to deploy something to production, right, I'll create my app, I'll Dockerize it, and then I'll deploy an instance of it to app service, right? But I also like to do a nightly build version of it. So in that case, what I do is I spin up another app service. That one, instead of being tied to a Docker registry, is actually tied to my source control. And then I create a GitHub action so that anytime I check in a change to my code, it automatically builds the code, versions the code, and deploys it to my app service seamlessly. So I don't have to do anything. So every night, I check in my code, I walk out the door, and I have a nightly build that's running out there for people to check out. So that's one of the strategies that I use that I think is really helpful. And that's one of the things I like about app service is that I have that flexibility to deploy the code or the container. I don't have to choose one service or the other. Yeah, we talked about that. So on the Google side, we have something called Cloud Run. It's basically the same thing as App Runner, where you're just taking your container and running it. But the thing that's kind of different about it is Cloud Run is more or less meant to be like an end-to-end solution, where they want you to build your app, or develop your app, build your app, and deploy your app all in the same service. So to me, it's a little wonky because it makes it a little confusing that if you just have a Docker that you want to just spin up, then it's a little bit more difficult. And the other thing too with Cloud Run is your apps have to be containerized. Again, more information, here's the links. Okay, good. Any questions? Okay, good. So we're doing on time. I think we're good. So serverless functions. Serverless functions are one of those things that I think a lot of people don't understand, especially when you start talking about, back in the day it was simple, right? We'd develop an app, we'd deploy the app, right? It was simple, right? Now we got like, okay, well, we can deploy the app, we can write it to a container, we can deploy the container. Is the container going to be a service or an app? Where's it going to run? And then we have on top of all that, we have this thing now called serverless, where it says, hey, I just have a piece of code that I want to run. Go run it. I don't want to maintain servers. I don't want to create Docker images. I don't want to do any of that kind of crap, right? That's the premise of where serverless came from, which was supposed to be containerless compute. But then the cloud providers go and screw up everything and make it even more confusing and say, oh, well, now we'll let, like your service, your functions now be loaded from a Docker container. So now it like changes like what the heck that means, right? So what these are used for is meant for very fast running processes, very small line of code, a process that's going to run very fast, and then you want to run it on an interval. Whether it's like, every time an event happens in your system, every time you get a new message in your queue, every time, every hour or something like that, you can run these type of functions, and they'll actually run that small little bit of code that you write without having to, spin up a new project, build, write the code, build the code, test it, deploy it, Docker, like all that other stuff. You just basically say, hey, here's the 5 lines of code I want to run, go run it. So that's where that's kind of nice. Again, it works well with containerized images, even though it says it's it's containerless compute, which is really weird, isn't it? That on one hand, they're saying containerless compute, and then they go up and say, well, we also support containers. Okay, so container-ish, if you want, compute, I guess that's a better way of putting it. The cool thing about this, and this is one of the things where these differ a little bit between the platforms, is the way that you can invoke it. So you can always manually invoke it. That would mean like I'm going to go into the console and hit run. I want to spin up a CLI command and hit run, or use the SDK, or hit an HTTP endpoint. There's events that would basically mean, hey, anytime. So let's say we have a SQS, right? So anytime a message comes into SQS, I also want to do, I want to log this event, or I want to do this action. So you can set up basically the way Lambda works is you pick your service that you care about, and then you say, okay, now what out of that service do you care about? Like message coming in, message going out, those type of events, and then it automatically wires that up. So anytime that something happens with that service, it'll automatically fire off your function. And then HTTP again. So this is actually one of the things that's really interesting that we need to talk about as well. And that is Lambda has the ability to run synchronously or asynchronously. Synchronously, what they mean in that is that means, hey, I'm only going to run one instance of this thing at a time. And if I get more than one request to run that, I'm going to queue up those requests until the thing is done running, and then I'm going to pick up the next one and start processing over and over. So that way it kind of eases the development in that I can be assured that 2 things are not going to run at the same time, depending on the type of app I'm trying to build with that. And asynchronously, it would be exactly what you would think it would be. Like, hey, I'm going to give you 5 requests at a time, spin it up, it's going to run in one of these 5 instances. They could be running all concurrently. So that's a very important distinction to make, because this is the way that both Lambda and Azure work, but it's not how GCP works. And let's compare it first to Azure. Azure is basically the same exact thing as what we just talked about here. The difference is, I think the Azure functions are a lot easier to use. I think the development experience is a lot better because you can do a lot of like localized coding and debugging and stuff like that. And there's even remote debugging where I can even remotely step through my function that's hosted on the server. I think that experience is a little bit better than what I've seen with Lambda, although it's been a while since I've used Lambda. The thing I always remember about Lambda is basically, hey, I got some code, copy, paste your code, or here's a little text editor. It didn't seem to be as great of an experience for me.
I think they've improved it.
Yeah, I'm sure they have.
Azure functions, but it seems like they've kind of made it, the console's pretty robust in terms of what you can do in it, and then also the local, if you're running SAM, locally, you can do a lot of your invoking and,
Oh, okay. Yeah, like I said, it's been a while, but okay, that makes sense. It makes sense that they would improve that, yeah.
it still took me a long time to wrap my head around it. So I wouldn't say it was like easy, but it's,
Yeah.
I think they've made improvements to it.
That's good. That's definitely good. The other big thing too is I think that Azure out of the box has more comprehensive triggers. Those are the things that trigger the function to run, the invocation methods. One of the big ones and most notable is cron. So if I'm using AWS Lambda or I'm using GCP, there's no direct, like, hey, run this at the top of every hour, or run this every 5 hours or once a day or any of that type of thing. What you have to do instead is you have to use another service to actually schedule that thing for you to actually run. And we'll talk a little bit more about that. We'll use here, let's actually go over there real quick. So using GCP as an example, if I wanted to schedule this function to run, I actually have to use the cloud scheduler, and I have to actually have it write a message to the pub sub, to a pub sub queue, and then I have to consume that queue, or basically wire up my function to trigger off of that message getting written to the queue. So see how that's a lot of extra work? Right now I'm using scheduler, I'm using pub sub, and I'm using function just to invoke a function on a schedule. Whereas with Azure Functions, it's built in. It says, oh, just run this. And the reason why I call it this specifically cron trigger is because it supports cron. So anything you can do with cron, you can do with that. So top of every hour, every 15 minutes, once a day, once every 5 days, like whatever schedule you want, you can specify with cron. And we talked about that. Okay, so now jumping back over to the GCP. So basically it's the same exact thing except for that scheduler thing I was just talking about. It has a very limited set of triggers. It only works off of GCS events, which is the global, Google, it's basically Google, S3 and Google. I forget what the name is escaping me for some reason. But basically I can listen to a file, so file events, or pub sub events, which is their queuing system. So queues and files are the only things that I can tie to, or HTTP. I can't tie to any other service, right? So one of the things that's really nice, and I think a lot of people use Lambda for, is they might use it for health checks in their system, right? Making, if something crashes or making do like heartbeat checks and those type of things. You can't do that as easily in GCP. So that's one of the big things, and that's why I point that out, is that it's very limited compared to the other two offerings. Okay, any questions about this before we move on? Okay, good. I know some of this is really dense. So if there's some things that are not applicable to you, let me know. I can go through some of it quicker. Yeah, and the other big thing too is that GCP has a very limited set of languages you can write in. So you can only use C#, Java, JavaScript, and Python. You can't do Go and a lot of the other ones that you can do in Lambda and Azure Functions. Azure Functions and Lambda language support is about the same. I don't know exactly one for one, but the majority of the things you would actually use are available on both. Oh, and the other big thing too, the other big thing too about Cloud Functions and GCP is they only run in that asynchronous mode. Again, asynchronous mode means that I could have 5 of these running at a time. So if you have a process where you want only one thing to be running at a time, you don't have that option in GCP. So what that means is that if you want to do that same type of thing in GCP, now you're doing a huge amount of workaround, just like we talked about with the cron scheduler, just to do something simple. Right now I'm involving multiple services and all this additional development work for what should be out of the box. Okay. We already talked about that too. So the next big thing is talking about Docker. So there's not really a lot to talk about with Docker. So you either use Docker or you don't use Docker. But basically, when we talk about Docker in the cloud, it means like one of 3 things, right? There's the registry, which is where we store our Docker images. There's the where we run our Docker images, like we talked about for like the app runner and stuff like that. And then there's Kubernetes, which we'll talk about in just a minute. And again, you can use the GitHub actions that we talked about before, which is really nice to actually build up your nightly images. And in AWS and GCP, same exact thing. I've used all three of them. I found like no difference between the three. They're basically exactly the same thing. I can deploy my container. I can take my container, hook it up to, as a source to something else and pull things out of it. It basically works exactly the same. So there's not really much to say with Docker. For those of you that are not really as familiar with Docker, but basically the premise is, again, this is a screenshot I stole from AWS. You're going to write your code. When you go to deploy your code, you're going to basically create a Docker file, and it's going to create a Docker image. With that image gets stored in your ECR, your Elastic Container Registry, and then you deploy it to wherever you want to run it. So that's basically how that works. So Kubernetes is, and again, this is one of those things like if you're using Docker, you know about Kubernetes. If you're not, then you're probably not familiar with what Kubernetes is. So there's a little blurb here about what it is if you're not familiar with it. Again, just like with Docker, Kubernetes in both AWS and GCP is exactly the same. Again, I found very little difference between any of them, just different names. So AWS is EKS, Azure is called Azure Kubernetes Service or AKS, and then Google is GKE for Google Kubernetes Engine. Okay. Sorry, what was that? Oh, yeah. All right, so the next big thing is file storage. So we kind of talked a little bit about file storage back, at the beginning when we talked about CLIs and things like that. So I think we all know what S3 is. It's object storage, it's file storage, it's blob storage, et cetera. Buckets have to have a globally unique name, and this is true with Azure as well. So in Azure, you also have to have a global unique name. The thing that's nice to note about here, and this is one of the big differences that's going to come up, folders are first-class citizens inside of S3. They are not in G3, or in, sorry, not G3, GCS. It uses the layout of like bucket, folder, file, so I can have a bucket. Bucket has folders or folders and files, and a folder can have folders and files and that kind of thing. Think of it more like a traditional file system. Unlimited size buckets, basically meaning you can have as many files as you want, you can have as big a bucket as you want. And you can store blobs in additional files. Blobs is just like, hey, I got JSON text or something. So instead of it, my file.txt, it's just a JSON blob. And we already talked about the naming. So with Azure, this is where it differs a lot. So there's not really the same exact thing in Azure that there is with S3 and GCS. Instead, what they have is something called a storage account, and a storage account has blobs. And it sounds like a very minute difference, but there are some limitations to it. So for starters, again, just like with S3, folders are first-class citizens. However, there is now a size limit. So a container, or a bucket, if you will, has a 5 petabyte limit on it. And there's also a limit to how many total buckets you can have within your Azure resource group. I think it's 250. So I mean, if you're at 250 times 5 petabytes before you're running out of space, you probably should be having a conversation with Microsoft anyways. But just note that there is a limitation here that there's not with the other two offerings. And the biggest thing here is that blob storage is actually one of the oldest Azure products, and it's not as nice as the other two. The other two were built from the ground up to be like a file system-like thing, where blob storage is kind of like, we got a storage account, let's add that type of thing into it. And again, you can store blobs in addition to files. And this is another big thing too. I know it's really hard to see. You guys would probably want to download this, but like when we talked about the S3 file name, instead of it being like an S3 path or like whatever the path is, now it's a URL. That's the only difference, but the URL is basically the same thing. It just now has all this, the buckets information attached to it. GCS, basically the same exact thing, except that there's no real concept of a folder. So if I create a folder, let's say I create a file that exists under a folder in GCP. If I delete that file, it'll automatically delete that folder once there's no items in it. So folders are not first-class citizens in GCP or GCS. So that's one thing to keep in mind with that. It's not a huge thing, but it is kind of something to be aware of. Because if you think like, oh, okay, I'm just, in my code, I'm going to write this, create the folder and then create the, add the files to that folder, then, it's a little different. Unlimited size, it stores blobs. I'm not actually sure if it stores blobs. I actually have to try this out. I've only used GCS for storing files. I actually want to try that out to see if you can actually store blobs in it. Because that I'm not 100% sure. I couldn't find any definitive proof one way or another on that. But I'll actually try that out. And if I find out, I can let you guys know. And then just like before, like we talked about the S3, is it has GS colon. And then more information. Okay, so I know it's a lot. You guys exhausted? I'm getting there. So the next things we're going to talk about is like databases. And some of these we'll kind of go a little quicker through because they're basically the same things, right? So in AWS, we have RDS, which is our fully managed instance of like MySQL, Postgres, or SQL Server. Cloud SQL is basically the same exact thing, one for one. I haven't seen any real differences between them that would note. The difference between those two and Azure is Azure likes to be different. Instead of having one database platform, we're like, nah, we're going to separate those. So for example, if you're doing SQL Server, you actually have 5 different options. You have like, well, Azure SQL database. You also have SQL Azure. Great naming there, isn't it? Isn't that awesome? Like, why you got 2 services with the same name? Yeah.
How do they do compliance?
In terms of like what?
Like, okay, in my environment, the place I work, is that we don't do that because we don't know how to keep it compliant. How am I going to know that their database, their instance, people are not good, you know what I mean? We're going to try to find out information about another company. I'm just curious, I don't know.
Yeah, I think a lot of it boils down to what type of compliance you're talking about in terms of like.
Sharing the same storage.
Yeah.
Are they on a different LUN or how are they doing it?
I think it depends on how it gets configured, right? So like in SQL's case, in like Azure, I can specify if I want shared instance, dedicated instance, and obviously dedicated, more money. But I can say, hey, I want my own dedicated metal. Yeah, I don't want anybody else's metal on my metal.
So the other ones are shared environment.
Yeah.
Shared Active Directory, same thing?
Yeah.
Okay.
Yeah. So the other thing that really comes in that's really weird about that too is depends on what compliance you're talking about, because there are other databases that you can deploy. Like for example, in GCP, right? We use what's that called? Yeah, no, not Spanner. What's the other one?
Talking like FedRAMP or something?
So our. Yeah, so that's the thing, like with ours, like FedRAMP's a really good example because that's actually what I was referring to. The services that we use are on the FedRAMP approved list. So we pick and choose our things. It is, yeah, but we try to find a way to minimize the cost as much as possible. So we don't necessarily use like the database like this. We actually use a pass version instead of like the.
So what would be the example of using this kind of?
This would be like your traditional application, right? So the question was, when would you use these type of databases? This is like your traditional application, right? I have my app. Let's say I develop it locally. It's running SQL Server. Now I want to take that SQL Server database and put it in the cloud. So now I want SQL Server, but instead of on a server, I want it in the cloud. So now using this service, I now have all the things SQL Server can do, right? Now I can do all the database stuff with it, right? All the, managing my clusters and managing like my users' permissions, like all that stuff you do on-prem, just basically shoving it to the cloud. That's what these are.
So let's say your application, it matures and it becomes a very big application, then you have to redefine it to become secure?
No, I'm not sure.
Well, I mean, if you're going to do a shared, just like a shared Active Directory or a shared
Yeah.
database, that means it's shared. That means it's not secure. That means it doesn't have
Well, it's not, I mean,
compliance.
it's got isolation in it. It's not multi-tenant. It's multi-tenant in the sense that I'm going to have, so basically everything in Azure, I can speak from Azure's perspective, everything in Azure is a VM, right? If I deploy a pass, let's say I deploy like a service queue or something, that is deploying a VM, which is running that, and Azure is maintaining that VM and everything for me, right? So in that case, they're on the same metal, in that I have this VM and I have this VM on the same metal, but they're separated because the VMs are separated, like she was just mentioning.
What about the storage in the background?
The storage would be the same way, because if you deploy a SQL database here, it's going to spin up, deploy a VM, install SQL Server, configure it, and do all that stuff depending on what you told it. And then it's going to give you, say, hey, here's your database access. Here's your connection string. Now go have fun. So that's the difference between some of the other database offerings. And maybe that'll make more sense when we talk about some of the other PaaS offerings. But basically, this is like taking your SQL or your MySQL or your SQL Server and shoving it to the cloud. So some of the what we call serverless, this is basically the counter to what we're just talking about. So we have things like Aurora, and this is basically, it would take like the concept of MySQL or Postgres and give it to you as like a service. So now I'm using it just like if it's a S3 or something like that. So I don't have as much control over it like I would if it was like the RDS instance. I'm not controlling all the inner workings of the database. I'm more or less saying, hey, here's my data, store my data, and now let me query and stuff like that. So I don't have as much control using something like Aurora as I do with RDS, which is why Aurora is a lot cheaper than RDS. And Aurora is actually meant for like really high availability and high performance. A big thing with that is like Cosmos DB is basically the same kind of thing, except not, because Cosmos DB is kind of like an odd duck. This is the document DB before document DB that became document DB. Like the really confusing thing. Like Cosmos DB used to be called Azure Document DB. I think there was a naming conflict, and AWS won. That's why document DB in Azure in AWS is there, and Azure is not. So Cosmos is really weird because it's relational, but it's also NoSQL, depending on how you want to use it. And to make it even worse, is it's not only NoSQL, it's multimodal NoSQL, which means I don't have to do just document database. I can do document, key value, graph, column, tabular, whatever I want. So it makes it really hard to compare like the two things side by side. But the thing is whatever I can do in Aurora, I can definitely do in Cosmos and then some. That's the big thing here. And that these are meant for applications that might have really high throughput. Like think of your IoT devices where it's writing a lot of requests from millions of devices at once. These are the types of databases you want to use. And this is the example of why I would use this over RDS. Is that RDS basically it goes back to that whole thing I was talking about earlier, where if I install like Rabbit on a VM, now I'm scaling up. I'm scaling the CPU and stuff to handle the more volume instead of scaling out. So this gives me the scaling out of that, whereas the RDS would be the scaling up. So that's the biggest difference between why you would use like Aurora versus RDS. Even though conceptually they're very similar, especially if you're doing RDS MySQL versus Aurora with MySQL. And then GCP has Cloud Spanner. And the only difference with Spanner is only Postgres. It's basically, here, I need a database. Here's your connection string. Let me drop some tables in. I'm good to go. It's basically, I don't want to say it's not a real database, but it's not as complete as what we're used to using. If we're doing, enterprise level applications and scaling and clustering and what do you call that? indexing, like how we do like create our B trees to do all our indexing and stuff like that. I don't have as much control over those type of things. And that's actually a good thing when you're talking about Aurora and Cosmos, because they're handling that scalability for me, so there's less chance of me screwing that up. So if I am using it as like an IoT database and I'm writing billions of records to it, it's maintaining the most efficient way to access that data so that I can guarantee that I'm getting that data back that I need in a relatively short amount of time. And that's why a lot of people have actually, if you have like small apps and not non-enterprise level stuff, a lot of people have actually forgone like the traditional RDS or traditional relational database management system and started using things like Cosmos, because say, hey, all they need is I got some tables, these tables join, I have some data in it, and I just need to handle tons of volume. I want it to read fast, and I want it to write fast. That's all I care about. So a lot of people, I've seen a lot of people actually switching to just using like Cosmos instead of like their SQL Server or MySQL stuff. Okay, so does that kind of answer the questions about that? All right, cool. So along the NoSQL route too, there's our document DB that I kept talking about. So document DB, if you're not familiar with what a document database is, it's not actually like files, documents. It's not like PDF files and Word docs. It's actually JSON documents. So basically JSON blobs that you're storing in your database. So the canonical example that I always use is like Twitter. A blob I might store is like your user account, right? So I have your account. Your account has your tweets. It has your followers. It has all your stuff in one nice JSON blob. I can just take that blob, give it back to you. You can read incredibly fast, because in those type of cases, think about like how you'd use Twitter, right? You're going to probably read 100 tweets to every one that you write, right? So so you're optimizing for things like read instead of write. Whereas SQL Server, for example, is the opposite, right? Because you're optimizing for the writes, and then you sacrifice a little bit of the read on it. So again, we have our old pal Cosmos. Again, it's same stuff we just talked about. GCP has their own offering. It's called Firestore. And again, it's basically the same exact thing as AWS. So as you're probably seeing a pattern here, most of the stuff that AWS does, GCP is kind of copying, maybe not to the same level of degree, but basically the same, except for the name in this case. Again, more information, you can go there. A couple of the other database types are like key value pairs. I'll just bring this up. So the big offering here in AWS is Dynamo. This is basically just storing key value pairs. Again, this is as opposed to like storing a JSON file. I'm just storing like, here's my key, it's a string, and then here's the value associated to that string. You can kind of think it almost like a cache in a way, although it's not a real cache. And there's some differences between why a key value is not a cache and that type of thing. Depending on your use case, it might be cheaper than using like a Redis. But basically that's what that is. Like I got some key, give me the value. So big table again is going to be exactly the same thing as RDS. The biggest difference though with big table is it kind of plays nicely with their other big data products like BigQuery. So a lot of the focus and opinions around how it was created are more centered around big data and BigQuery and that type of stuff, and more analytical workloads. So keep that in mind if you need that. I'm convinced that nobody really uses like cloud databases or column databases and graph databases, so I didn't even bother doing those. Documents and key value pairs are the two most common types of NoSQL that people actually use. The next big thing is Redis caches. So a Redis cache, and see this is another example of where you have like several different offerings, right? So in AWS we have Elasticache, which is kind of a Redis-like cache that's as a PaaS service, and then you have Elasticache for Redis, which is basically the same thing as what we talked about with the databases. I'm going to take Redis and shove it in the cloud. So the Elasticache for Redis has a lot more features and stuff in it. It has more of the things that are in Redis that you might care about. But at the end of the day, all it is it's just a super fast in-memory cache that gives you things like high availability. It's distributed. It's got secure data access, very low latency, those type of things. If you don't need quite that much beef, and you're just trying to get started and you want a little bit of caching, I would actually recommend using Elastic Cache without Elastic Cache for Redis. So without the for Redis part. And it's actually a lot cheaper, and it does a lot of the same things. This is meant for when you have really large applications and you really need the features of Redis, or you're trying to use some of the plugins and other stuff for Redis that would not be available for Elastic Cache. Okay, and again, the other two are basically the same exact thing, just different names. So in Azure, they call it Cache for Redis, and then in GCP, it's just called Memory Store. Okay, any questions about caching? Okay, good. So another big one is data warehouses. And these are specifically like serverless data warehouses. So instead of taking like your, like we talked about the other databases, instead of just taking it and shoving it in the cloud, these are meant to be cloud first services that are centered around analytic workloads and storing your data. So it has a lot of performance benefits built into it. Like I said, it scales out instead of scaling up. It's high availability. It's a lot lower cost and those type of things. So in AWS, we do something called Redshift. And I just realized that I forgot to update the name for that. That should not be Azure Cache for Redis, because that was the last one. I forget what Azure's. Yeah, I think it's Azure Data Warehouse. And then there's BigQuery in GCP. So BigQuery is, again, where we talked about, like, big data, which is typically what you're talking about when you're talking about data warehousing. Because when you start getting to warehousing, that's where I have a lot of data. Now I'm trying to rationalize stuff about that data. So that's where I create things like star schemas and all that kind of stuff to do like analysis to say like, okay, well, I'm Amazon. We got billions of orders this quarter. Tell me some stuff about that, whereas I can't just necessarily query every order and stuff like that. So that's where a lot of data warehousing stuff comes into play. Yeah, so basically, not much to say. Again, it's just basically the same exact thing as what you're seeing with Redshift. I haven't really noticed much differences, but I don't do a ton of this type of work. And the stuff that I have done has been very simplistic comparatively to what some companies are doing. So take that with a grain of salt. The next big thing are queues. And I do a distinction between queues and like event sourcing, or not event sourcing, but event streaming. And we'll talk about that in just a second. But basically, our queues are where I take a message, and I'm going to pop it on a queue, and I'm going to use that as a communication mechanism between two different applications. So in Amazon, we have our SQS. It's our fully managed queue. Again, so instead of taking a VM, spinning up, dropping Rabbit on there, I can say, hey, use this. And now I get all the same benefits we talked about, scaling out says scaling up, pay for what you use, it's off when you don't need it, blah, blah, blah. Serverless, handles, huge volumes. Standard queues have unlimited throughput. So technically what that means is I can put billions of documents in there, or whatever I want in there, and it'll just chug it like it's nothing. It won't start slowing down or do that kind of stuff. But there's also FIFO queues. FIFO meaning first in, first out. These are more specific to, like, let's say I'm like Amazon and I want to process orders, but I need to make sure that the inventory is there, right? So I need to make sure that the orders get processed in the order that they came into the queue. So I want to make sure so I want that distinction that, hey, I want to make sure that this first thing gets processed first, instead of, these 5 things getting kicked off at once, and now this one finishes before that one. So these have high throughput, exactly once delivery, and then, like I said, first in, first out. It also has support for dead letter queues. So that's where, like, hey, I have a toxic message that got put into my system, my application, dies trying to process it. Because I don't send the acknowledgement, the message goes back to the queue, gets picked up by the next worker dies, gets put back. So it has a lot of that kind of stuff in it where you can set like, retry limits and stuff like that. Say, hey, if this thing fails like 5 times, throw it to the dead letter queue. And there also supports a variety of different queuing patterns. How many people actually do queuing right now? Quite a bit. What kind of queuing patterns you guys using? Using like worker queues, or using you doing like pub sub or topics or any of that kind of stuff?
Not so much with SQS and subscription polling, and then event-based bandwidth consumption.
Okay. We'll talk a little bit more about the different queuing types to see a visual of what those things mean. But yeah, so basically it supports different strategies. I basically just use the worker queue approach as well. Again, Azure has Service Bus, which is basically the same exact thing. I haven't found any differences between them. I use them both basically the same exact way, sending acknowledgments, messages in flight, all that kind of stuff.
A service bus usually delivers to multiple endpoints, right?
It can.
So
Yeah.
Does Azure Service Bus act as a queue and a service bus?
Yes, it can. It depends on how you configure it. Yeah. Yeah, and see that's where it gets confusing too, because you have Service Bus, and then you have event hubs. And event hubs are basically like more of what you're talking about. Like it's basically like almost like an SNS, almost like SNS with SQS combined, if you will. And that I can have topics have subscriptions are called multiple queues. So it's basically kind of like that together. But if you're looking at a direct comparison between just message busing or using a message queue, you would use Service Bus over that. Yep. Pub sub is basically the exact same thing. It's just very simplistic, and it only supports the pub sub subscription pattern, as the name implies, pub sub. I'm not going to really spend much time talking about the different types, but the other big thing too is that GCP can also support streaming like Kafka. I think Service Bus can too now. I haven't really played with it though. And typically you would use other like event hubs and some of the other things if you're trying to stream data. So the big difference between a message queue and streaming is a message queue has all the details that it needs in a single small message, right? So if I'm trying to process an S3 document or something, I'm just going to pass the S3 document name into the message and then let that, go pull the message and stuff like that. Streaming is where I might actually take the file, split it up into chunks, and then send the chunks down there. And then you have to wait for all the chunks to come into play. So it's a vastly different way of building your applications, because you'd have to wait for those chunks instead of just getting what you need. Yeah, that's good. So going back to the Azure discussion too, there's another thing too that makes it even more confusing, because now there's actually, remember when I talked about the storage counts back when we were talking about the blobs and the file storage? One of the other services within that storage account is called queues. Again, it's one of the first Azure things, so it's not as robust as some of the other ones. But it is still a thing. It still works basically the same kind of way. And the biggest thing too is if you're trying to figure out if I need Service Bus or if I need the storage queues, go to this link. This has a really good write-up around why you would use one versus the other. I don't really want to get into that because I was getting a little too into the weeds. But I did want to share this link because I found this resource and I thought it was really valuable, so I wanted to share it. And then these are some of the patterns we were just talking about. This is kind of a visual to show some of you that may or may not be familiar with queuing strategies. So when we talk about pub sub, what are we talking about, right? So for example, the publisher writes a message to a topic. That topic then writes it to the different queues, right? So each of the queues can be a subscriber to a message, and then it can automatically get that message every time it gets put in there. Worker queues is where one thing writes it and then many things can pull it off. So if I'm trying to, process multiple things at a time, that's where worker queues come into play. And then topics and subscriptions and stuff like that are basically the same as the publish subscriber, but now I can have topics and then I can filter on those topics. Say, hey, anytime a message comes in and it has the type of this, and it meets this filter, then write it to that message. It's basically all the same things. It's just you're building features on top of it. Okay. So the other thing we're talking about, so those are message queues. Now we're going to talk about streaming queues. These are like your Kafka-like things. So there is like a take Kafka, shove it in the cloud offering for all of them. But if you want the serverless PaaS service out of the box that does that same type of thing instead of having to shove Kafka up in the cloud, what you would use is these services here. So Amazon has Kinesis data streams. Again, it's fully managed serverless data streaming service. So it can take a lot of data at a very high volume and actually way outperforms a lot of the message queuing stuff given the way that it's constructed and how it processes messages. This is really useful if you're doing things like IoT, a lot of logging across your applications, and a huge amount of analysis stuff, some machine learning stuff as well. These are the event hubs we're talking about. Basically, it's the same thing as that. So the event hubs are more of your streaming, and your service bus is more of your message queuing. That's the biggest difference between them in terms of like how you actually utilize them. And then for Google, they don't actually have a serverless version. The only version they have is basically a hosted Kafka. And they actually partnered with a third party called Confluent to actually create that. So it's not actually strictly just Google. So that's one of the things going back to like our discussion earlier about compliance. That's one of the things where like that's probably not going to be like FedRAMP compliant because it's third party and data access and all that kind of stuff. So now the other big thing to talk about is something you guys may or may not be aware of, depending on the type of work you're doing and how much data you're working with. But there's actually like storage migration devices. Let's say that on our on-prem servers, we have like petabytes of data that we need to take and shove into the cloud. Well, the easiest way to do that is you get something called an appliance that gets sent to your office. You plug it in your network, copy the files on it, and send the appliance back to the cloud provider. I'm sorry? Yeah. Yep. Yeah, so in AWS, the biggest one, or the most common one that I've seen is called Snowball. I think there's also Snowmobile, and there's another one, Snowcone, yeah, that's it.
How do they sync it? How do they keep the data up to date? Because you're going to send it.
No, so this is basically meant to like, hey, we're on-prem, we want to move into the cloud. This is that one-time migration of how we get our data into the cloud. This is not necessarily going back and forth. You could use it that way, but typically it's meant for ingress.
It's not going to happen. It's going to take some time.
Yeah.
If they're working that day, how are they going to get the data? How's it going to sync the data that they're still working on-prem or no? Are they going to do it a weekend or how are they going to do it?
Yeah, it basically plugs in. Yeah, basically plugs into your network, and you have a network share on her.
Then you're going to put it in a box and you're going to send it up to AWS.
Yeah, yeah.
What about those days that you're waiting? Right?
You have to track the delta yourself. Yeah,
How do they do that?
you have to do it.
Send them more data?
Yeah.
So you take the delta basically over, and then you send that over the wire.
And then how do you have another program that keeps it in sync?
I think that, I know.
Well, the
Snowball has
yeah.
something that helps with
We use this program called HighStack, and what we
Yeah.
do is we replicate the data of the server.
This is not necessarily. I mean, you could use it for that, but it's not necessarily meant for like replication, like how you do like SQL replication.
Get that, but
Yeah.
when you bring a server on, and
Yeah.
it takes a while to replicate the data, okay?
Yeah, yeah.
And then once it gets synced, we can say, okay, let's sync it every 15 minutes. We'll wait till Friday night, and we'll say, okay, now we're ready to say that this data is the same.
Yeah.
Bring it over, and they don't lose any data.
I think I think the premise of, and this is the way that I've always used them, is that we're on-prem and now we're trying to move to the cloud. So that cutoff is done. So now we move the data to the cloud. So from this point on, there is no like syncing the data because we're using the cloud database instead of our local database or whatever service. We're now using that instead of this.
You're not bringing the server, you're just taking the database.
Correct. Yeah, this is just meant for data ingress.
databases. It's meant for.
It's meant for files, yeah. It's basically saying, hey, I got a ton of files. I need to get them onto the cloud.
Yeah, so you use like timestamps and stuff like that. Say
So we actually do, so even though we're in Google Cloud, one of our clients is in Azure. So we actually, like every month, we get sent 3 data boxes. We have to load up all the files. We got about 1 billion files. We send them every month. We load up all those files into data boxes, ship it off back to Azure. It gets uploaded into their Azure environment, and then then they have all the data. So that's the easiest way that we found to take, when you have like terabytes and terabytes of data, to just send it over. Because if you,
That's definitely, but what I'm saying, like, is we
yeah.
did the migration, and we migrated everything up to our cloud, and then we had to make sure they're in sync, because they're still working for the last
Yeah.
4 days. So we did a final sync, and then we said, okay, turn off the on-prem server. We have all the networking and everything
Oh, yeah.
set up. I just wondered how you guys do it, but I don't know.
Yeah. Yeah, I mean, it's going to depend on, so it goes back to his point about the delta. It's going to depend on how much that delta is. Is that delta a couple gigs, or is that delta like terabytes? If that delta is terabytes, then you'd want to get a new data box. You'd want to load your data on it and reship it back off. And now that would put your cloud in sync with that. But if it's just small amounts of data, like maybe a few gigs, then you would just write a service and you would just manually upload it into the cloud. Programmatically upload it into the cloud, essentially.
Sounds good.
Yeah.
It don't work that way for me sometimes.
So usually it's overnight. So we with the way we do it, it's always overnight. So we get the data box overnight, and they get it back. It gets back into Azure overnight.
Into their environment that quick.
I think so. Yeah. I'm not exactly sure on the data load side. I'd have to check with my client to see, because I don't handle the communication with there.
They're at least 10 gigs.
Yeah, I would imagine there's some kind of delay depending on how big they are, how much data.
The snowmobiles are like,
Petabytes.
yeah, well, it's a full-on semi-truck that you plug in. And that thing is, yeah, it's fast. It's got a big plug, yeah.
Yeah, they do.
That's the same.
I mean, even ours are little boxes, and they're still like thousands and thousands of dollars just to rent that thing.
And also, I want to add that AWS has a database migration service just for migrating database.
Oh, okay, perfect.
EMS.
Oh yeah, that's right. Yeah, yep, that's absolutely right. Yeah, so if you're migrating your data, yep. Yeah, so that's the other thing too that gets confusing is like, well, what are we putting up there, right? Because these are primarily meant for like files, like you alluded to earlier. So that's basically what I wanted to say about this. Again, they're all basically the same. It's here's an appliance, plug it in your network, load your files on it, send it back. They all kind of work the same. They range from like little boxes to, like you said, semi trucks. But yeah, so that's basically what those are. Another big thing so this is kind of transitioning now into like some of the big data and AI ML stuff. This is where I spend a lot of my time. So one of the concepts we have is something called a data lake. This is basically a centralized repository where we would store like our documents. So it could be structured, unstructured data, whatever. So this is meant for when you have large amounts of data and you're trying to, like, let's say do machine learning against it. So like in my case, we do a lot of document processing. So we might have like billions of documents, say, okay, here's your billions of documents. Go do some machine learning against that to figure out, how to classify those or how to extract data out of them. So one of the big things, this is one of those big fancy terms you hear. Well, what I wanted to tell you is that the way that services like, blob storage in Azure, S3 in AWS and GCS are built, basically data lake is just a big fancy term for those buckets. That's all it is, really. So if you look at what's actually happening under the patterns, it's basically just using those services. Azure does take it one step further, and they do have something called Azure Data Lake, which again is backed by blob storage. But it adds some more niceties around, like, how to like categorize your data and do stuff with it. I don't do a lot of work with it. I don't really find it too useful. But if you're doing a ton of data and stuff, depending on the type of work you're doing, that might be useful. And here's some additional links if you're interested in that kind of thing. You can look at these. Here it shows you like what is more in depth of what is a data lake and how to get this stuff set up.
AWS has a data lake service as well. It's basically just an API to access all the different disparate services of data.
Oh, so if you have a separate buckets, it'll bring it all into
Yeah,
one.
it comes into one API.
Oh, okay. Okay, that actually makes a lot of sense. Yeah, that would make it a lot easier to consume from. This is where I spend a lot of my time, is Hadoop and Spark. If you're not familiar with what Hadoop is, it's basically, I have petabytes of data, right? Like billions of files. And I need to run a process against those files, right? You know, it needs to, you know, let's say we're gonna do OCR, we wanna classify the page, and then maybe save it to a database, right? So those actions. Well, when I got billions of files to process, a lot of our normal processing things go out the window, right? Because, you know, file systems start slowing down, latency between certain aspects get, get really, really greatly increased. So basically what Hadoop did is they've said, okay, we're gonna take and we're gonna build out an environment. This is where we're gonna create a file system called the Hadoop file system. We're gonna create an interface for how to create workers and then like all the processing stuff that happens within that. So basically it's thinking about like the entire processing thing you would do across your different services, all squeezed down into a box called Hadoop. Spark basically sits on top of Hadoop, and it makes it a little easier to work with. So if I'm not trying to, utilize the file system and a lot of these other advanced features, it basically gives me a lot of shortcut. It makes it really easy for me to do stuff with it. Yep.
Take a copy of all this data, or is it usually existing data?
Hadoop keeps it in memory.
Yeah, usually in memory, yeah.
It's actually using the existing data.
Yeah, Hadoop will load everything into memory across a cluster.
Yeah. And I think it also depends on how you configure Hadoop. Because like a lot of the way that we use it is we're actually using Spark, and we're not actually loading the data in memory because we're not using the Hadoop file system. We're just using like our GCS buckets directly because it's quick enough. So that's one of the things that's nice about Spark is it kind of gives you some shortcuts through that where I don't have to put my data in there or I don't have to load it all into memory. I could just load it when I need it. So in AWS, we have the Elastic MapReduce. And then this is basically a lot of the Hadoop features, things like Hive and Yarn. It allows us to process a lot of things concurrently. It basically spreads out the workers and stuff, and it manages that process for us. And again, you can use S3. You don't necessarily have to use the Hadoop file system. Azure, it's called HD Insight, exactly the same thing. It does add a few other features like Zookeeper and stuff like that depending on what you're doing, you may or may not care about. I don't really use Zookeeper or Pig and the stuff that we're doing, but we're also not doing a lot of MapReduce stuff. We're actually just doing we're just using Hadoop as a processing engine where we needed to manage I have a process of 180 workers that I'm going to process and let it spin those up and separate, send work out to those as needed. Dataproc is basically what we use for that, and it's the same exact thing as MapReduce. It scales very nicely, especially because we're using Python and PySpark. It easily integrates with PySpark. So it's really nice that because I'm using PySpark, I can actually develop everything locally using the PySpark platform, if you will, like a local instance. And then I can take that code once I get it debugged and working, and I can shove it into Dataproc, and it just works. So it handles a lot of that stuff for me. So I can work out all the bugs and all that kind of stuff before going up there. So that's one of the things that's really nice is that it supports PySpark. Again, that's one I use every day. So another big thing we do is we do a lot of document processing, a lot of machine learning. So what goes along with that and what our biggest time suck and our biggest expense is OCRing, optical character recognition. So, we have Textract, which is really nice because in addition to just, normal OCR, like, hey, find the characters, it actually has a lot of intelligence in it that it can do things like handwriting recognition. It can find tables within a document, and it can properly extract that data in a tabular format instead of like mushing it together, and all that kind of stuff. It's very accurate. Much, much higher than Tesseract. So one of the things I will say as a general statement is that all of the cloud offerings for OCR are vastly superior to anything else that I've used. I've done a lot of GD Picture. We're experimenting with Abby. Abby is supposed to be really good, but we haven't really gotten a chance to play around with it yet. We use things like GD Picture and some of those other ones, and they're all right, but they're just not as accurate. Especially Tesseract. Tesseract works good if you can somehow find the perfect model, but you'd have to find the perfect model, which a lot of times doesn't exist. So whatever these cloud platforms are doing, you're using like a next level of higher intelligence than what just Tesseract is using. It's not like doing like MNIST where I'm just trying to say, hey, is that an A or is that a 9? That type of thing. Do you have a question? Oh, so, yeah, sorry. So in Azure, it's called Azure Computer Vision OCR. It's basically the same exact thing. Again, speed and accuracy is very comparable. Textract is a little bit better though because of the table recognition. So if you have a lot of forms and things like that that you're trying to process, I would actually use Textract over the Azure offering. And then GCP takes it kind of one step further. They have something called Document AI. So on the surface, it is like the same exact thing as Textract. It does the OCR, it does the table, it does the handwriting recognition. The speed's about the same. It can do key value pairs. It has a lot of built-in processing for, let's say, for example, I'm scanning in invoices, right? So in addition to just OCRing the invoice, it can automatically extract all that data, give it back to me as key value pairs, and it can do all that kind of stuff without me having to write any kind of code. But it also gives me the ability to actually write my own code in there so that I can actually do it across my custom document types or my own type of invoices, that kind of thing. And as I just alluded to, it's more than just OCR. It's kind of a platform. So you could take as much or as little of it as you want. And then these are some links for that. So OCR is, like I said, given the work that we do, this is one of our, one of the things that's most important to us. So this is something I've actually put a lot of research into. Okay. So the next thing that kind of goes along with these is notebooks. Notebooks meaning Jupyter notebooks. So the landscape has kind of changed a little bit over the past couple of years. So it used to be, I have a Jupyter notebook, and I can take it and I can kind of just deploy it to the cloud, and then I can run it, right? So like that's the way it used to be. It's kind of different now because now what the offerings are is that you actually get like an entire environment. So you can say, hey, I want to spin up an entire like Jupyter, there's something called Jupyter Lab. I could spin up an entire Jupyter Lab environment, and then I can do all of my development. I have a VM and everything all right there in one tight little package. I can do all my development, model building, and deployment and everything right there, and we're good to go. So Amazon is called SageMaker Studio. SageMaker is like their generic machine learning. There's different offerings under that. Studio is the one that we're talking about for the notebooks. This is basically that whole environment that we're creating to build, deploy, test our models. Azure is actually really cool because it can be used the same way. You can use it as like Jupyter Hub and all the stuff we just talked about. You can host models just like, so Azure ML is kind of the platform. There's not like a distinction between, so like in Amazon, there's SageMaker and SageMaker Studio. In Azure, it's just Azure ML, right? So it's the entire platform. So I can use it to host models. I can use it to build models. I can do all that kind of fun stuff. And one of the things I want to show you here in a second, and this is one of the things I think is really cool about learning about different cloud platforms, is that there's an offering in there called Azure ML Studio. And this is basically drag and drop machine learning. And I'll show you what that looks like in just a second. It's really cool because it gives me a very visual way of laying out my application and actually creating machine learning models without having to write any code. And it's the only platform that I'm aware of that actually offers that. Vertex AI is basically what we use. It's basically Jupyter Hub. So basically it spins up a Jupyter Lab environment. So it gives us a notebook server. It gives us VMs associated with it and all that deployment stuff for us. Basically the same exact thing as SageMaker Studio. So this is might be kind of hard to see, But this is that diagram I was talking about, where I could just drag boxes on here. So I can say, hey, take in my data. I can say, here's what I need to do to basically my ETL step. I need to transform it into this. Clean it, do some processing here. I can split the data into a training and test set. I can run the training set against my model, which uses the linear regression, which will train my model. And then it'll run through a scoring method. And then at the very end of it, what I get is I get a service. I get an API endpoint that I can hit that takes that model, deploys it, and runs it for me. So all I gotta say, hey, here's a document, go classify it for me. And that's really cool. I've used this for quite a few years, and it's really, really awesome. I love that. How are we doing on time, by the way?
A quarter after.
Are we so good, or?
You're running long, but I mean, it's up to you, man.
I think I only got a few more slides anyways, so we might as well go ahead and finish out then. So the other thing is machine learning as a service. This is, again, where we could take our machine learning model, throw it into the cloud. So I can say, hey, I got this document classifier that I wrote. I can just deploy it as a service. Now I can just hit that service as an endpoint. If I'm going to do that, I'm going to use SageMaker. And if I'm in Amazon, Azure ML again, because Azure ML is all the machine learning stuff in one. And then Vertex AI. Again, doing model hosting, it's exactly the same way. They all work the same way. I could take like an Onyx model. I can deploy the model. I deploy the code with it, and it just runs it, creates a service, and does all this stuff for me. They work exactly the same way. Exactly the same amount of time in terms of latency and performance and things like that as well. So I haven't found any noteworthy difference with that. And AutoML is basically where I don't want to write code to, I don't want to, we don't have machine learning engineers or whatever, and I need to build a machine learning model, but I don't really know how to do that. So I'm going to let it do it for me. So let's say I want to do image classification. I can say, hey, here's pictures of zebras. These are pictures of giraffes. And then I can let it figure out what a zebra looks like or what a giraffe looks like. So if I'm in Amazon, we'd use Autopilot. This is a service that allows us to do that. Again, it's under SageMaker, so SageMaker Autopilot, as opposed to SageMaker Studio or SageMaker that we just talked about. Azure uses something called Custom Vision API. And I actually want to show you a couple slides of this because this is really neat how this works. And again, this is the only offering that I've seen that kind of works like this. But basically, it allows you to create your own by just giving it images and a label, and then it trains the model, and I'll show you how that looks in just a second. And then GCP kind of works the same way. The models it creates are pretty accurate. It's just as accurate as the other two as far as what I've seen, given the tests that I've done with it. But let's take a look a little bit more at the Custom Vision API. What's really cool about it is these are products that are meant for being able to create machine learning models, even without being a developer, right? So not only is it no code, you don't even have to be a developer. So there's a UI, you go in here and say, hey, I want to create a new project. I upload a zip of my images and says, hey, these are my zebras, these are my giraffes. And then I click the train button. And this might be really hard to see again. But when I click the train button, what it's going to do is it's going to basically train my model. It's going to say, hey, model's done. Here's how it performed. So it's going to give me my precision and my recall, which are the two things that I care most about when I'm training a model. And I can see that if these are high enough, then it can accurately predict, a zebra versus a giraffe. So once I do that, then I can go in and actually do a prediction. I can say, hey, here's an image I want to predict. Go ahead and predict. And then it's going to come out with my different labels and the different percentages. So I can say, hey, I'm 99% sure that this is a pineapple. So you can see, this is what's really cool is this is done with no code. And you can spin this up and do this and create the service. So once that trains the model, you automatically have a service you can call, an endpoint you can call, and it actually gives you the code that you would need to actually make that call. So you don't even have to have any guesswork of trying to read through the documentation to figure that out. And I know we've gone really far over and stuff like that. There's certain things we know we didn't really get a chance to talk about. IoT, networking stuff. The on-premise cloud we kind of talked about earlier with the Azure Stack and stuff like that. And this kind of we talked about earlier too, like entire environments can be scripted using Terraform or Ansible. Bicep, that was the Azure one. Bicep's the other one. I think Bicep is only for Azure though, but it's the same thing as Ansible or Terraform. As far as architectural considerations, I would say that there's not really any. So if you're already doing AWS and you're trying to port your application or your application stack into another cloud, as you can see by going through a lot of this, a lot of it's basically the same. And there's a little bit of difference between things, but 99% the same thing, right? So there's not really any special design considerations. I would say that, it's going to completely change your architecture. However, there might be new services that you want to utilize, like what we just saw with the custom vision. If you wanted to build some kind of object detector or something, now you can do that and utilize that service. Because there are things that are offered only in one provider than the other. And Azure's not the only one. AWS has a ton, and GCP has a ton as well. We don't really have time to get into all that. But basically, this is where I wanted to leave you guys with. If you have any other questions, I'll stick around. If you want to hit me up on Twitter, my username's here. The GitHub repo here is where all the slides are. So you can have access to all that. And then these are 2 really good links that I found that actually goes into different offerings. So like, let's say, for example, like, other than just the ones that I talked about there, it'll actually show you like all the possible offerings for that. And then you could actually compare and see if one fits your use case better than the one that I pointed out here. So with that, I want to thank everybody. I appreciate it. Thank you.
Is autopilot only for images?
I don't think so. I think you could do text and other things with it as well. Yeah, I'm pretty sure there are. Because like even in like the Azure world, there's something called cognitive services, and there's cognitive services for speech to text, text to speech. There's text classification and things like that. Yeah. So basically, they do have multiple offerings, like if you want to do sentiment analysis and stuff like that. Yeah.
Can you talk a little bit about the IAM permissions? Because I've heard like permissions are like a lot easier in GCP. Like it's like a folder structure versus like IAM policies can get really complex. And I don't know. It's, just what's your top take on like the permissions in IAM and the 3 providers?
I don't do so. I work at a large corporation, so I don't get into the weeds on a lot of the, I would call it enterprise level IAM. Most of the stuff I've done is basically like, hey, I have a bucket, I need programmatic access to it.
Yeah.
I haven't really done a lot of the complex stuff. From what I understand, they're pretty similar. And I think if you're trying to do complicated things in one, I think it's going to be pretty much equally as complicated in another. I don't think any one is going to make that a lot easier than the other.
I think Azure does it better than
Probably because of the Azure Active Directory and some of that.
Their idea is like, how we do a bunch of different like multi-account structures and stuff like that.
Yeah.
In Azure, everything is one account, but they have different subscriptions, and that's how you separate your
I
context.
remember you and Jordan were talking.
Oh yeah, like
Yeah,
resource.
and
really
it-
intrigued by it.
It just makes everything so much easier.
Yeah. From that perspective, I think you're right, absolutely right. Because in Azure you have the subscription, and then subscriptions can have resource groups, and resource groups can, and each can have their own billing, right? So resource groups can be billed separately than the subscription.
from the ground up.
Rather than like
Yeah.
an afterthought, like at least the way that Amazon does it. I don't know GCP's, but Amazon's it was an afterthought.
GCP is basically the same.
Yeah.
Because
Good.
because basically you just have the project, what you call the project. Let me think about that.
Google's your authentication.
Yeah, so in Google, I'm trying to think of how it works in AWS, but in Google you have the concept of a project, and basically that'd be like your resource group, if you will, and then everything that you build is in that project, which is assigned to a region. So that kind of would be kind of analogous to. I just don't think it's the exact same thing as like a resource group. I'm trying to think how does that work in Amazon?
Build a whole different account.
Yeah, that's what I thought. That's what I thought. Yeah.
Okay,
Question?
question for you, I mean, because I'm in like sales architect, sales role right now, so we get in front of a lot of customers, and the question I get from a lot of people is that they kind of get put into a square peg or a round hole or whatever, and their bill just goes like this, but they're using those services, and I try to help them, and like, you can't come to our cloud, because how would you get out of that predicament of your bill? Remember that thing that we talked about?
Yeah.
Yeah, they're very sticky. How can you, I mean,
There's no network.
so you can't.
It depends. It all depends on what aspect of it you're talking about. So, like for example, I had a client just recently who is a rather small company, but they have customers that wanted to, run stuff in an app service. But the app service was really kind of expensive for what they were trying to do. So we actually kind of built it in such a way that we did like a multi-tenant app service, if you will. I wouldn't necessarily recommend that because that's kind of an anti-pattern, but there are ways to cut down the cost, and that's one of the things with a lot of why I say prefer PaaS to IaaS, because like SQS, you're paying for what you're using, right? So if you're not getting messages in, you're not paying for that. If you have a Rabbit server, you're paying for that thing to be up, whether you're getting messages or not. So there's a lot of things you can do like that to really cut the costs. And I think like even going back to the thing earlier where I said like service bus versus storage queues in Azure, that would be a good use case of why you'd want to use one over the other. Is I think storage queues are probably a lot cheaper than service bus. So it becomes really difficult because it depends on what part of it you're trying to optimize. And things like that, and because there's sometimes you can use this service versus that service, and they 90% do the same thing, but there's a vastly difference in cost or something like that.
We looked at the hosting cost per account here in a SaaS environment, right? So like that's the KPI you track. And so even though your bill might be going up, but maybe if your architecture is scalable, your actual cost per user is going down. So there's like, but if your architecture can't support growth, your bill is flying through the roof, you have to re-architect.
Yeah, and
you're gonna pay the cost of.
Yeah, if you do it wrong.
yeah, and that's why scaling up versus scaling out.
Moving to another provider is not gonna, you're just gonna take the problems from.
Yeah.
Yeah.
Yeah. And that's why scaling up is a much bigger problem because it's way more expensive to scale up than it is to scale out. CPU, like adding CPUs and adding memory is always way more expensive than. Yeah. 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 And another thing you can do too is you can kind of piggyback off of services. So let's say, for example, I'm doing queuing and I have two different customers and I want to utilize the same queue, if you will. One of the ways you could do that is you could put like a tenant ID and make it kind of like a multi-tenant, kind of going back to like her example earlier, like the multi-tenant database. You could do that if you're paying for like. I'm trying to think of how RDS pricing works versus SQL. So like SQL Azure, for example, right? You pay per database, not per database server. So like if you think about like your on-premises, you can have one database server. Yeah. So like, if it's like let's say it's on-prem, and I have one SQL server that has 10 databases, that would be one server, right? But when I go to put it in the cloud, that's now 10 instances. So that's an example of where you get some money as well. So yeah, there are multi-tenant ways and other ways of doing it. It just all depends on what the apps are doing, what kind of volume they need to support, what you're trying to optimize, how you're trying to move from one to the other.
Cool.
Yeah, there's no real easy answer I can think of for that.
Good job.
Thank you, appreciate it. Thank you. Yeah, I know it was really dense, but I didn't know because like coming into it, like I don't know what people's backgrounds are, what things people care about. I'm trying to share my experiences of like how I use one versus the other, and